Okay, the beginning of the second part of Unit 1, transformations. Transformation is moving a shape to a different location using a slide, flip, or turn, but still keeping the same size, shape of the original image, also called a pre-image. So if you think about when you transform something, you change it. When someone goes through a transformation, they change. Okay, caterpillar transforms into a butterfly. So we're going to talk about three main ones here. There is also a transformation in the shape and size, but we're not doing that right now. Right now we are just going to translation, which is a slide. When you move a figure left, right a certain number of units, and up or down a certain number of units. We have a reflection, which we also call flip, when we reflect it or fold it over a given line. And if you think about a reflection, if you look in the mirror, maybe after watching the video, go to the mirror and look at yourself, and if you have a ring on one hand, like your left hand, what hand is it on in the mirror? It's your right hand. Okay, so it flips. The ring flips from your left hand to your right hand. Or if you have maybe a nose ring on one side of your nose, and in the mirror, it's on the other side of the nose. So go to the mirror and just check that out. Maybe hold up your left hand. You'll see your right hand go up in the mirror. And then there's a rotation. If you think about the word rotate, it means to turn or spin. So we rotate around a given point. We kind of stick a needle, like a pin, in the object and then just spin it around that point. So here we have some shapes, some triangles. Okay? And so the original one is an orange. I'm going to take this green one. Notice how the green color coding right here says translation. And translation just means to take it and literally slide it as many spaces as you want. Up, down, left, right. You can do a double translation. We do it like this. So if I just take the figure and move it around, this is a translation or a slide. You can see why it's called a slide. In pink, we have a reflection. This has been reflected over this axis. If you can imagine folding the paper over, it would be right here. Okay? Let's see. I can do this. I could also, as you can see, if I would have folded this down this way, notice it's 2 spaces away from the x-axis. I could also fold it down over the x-axis. So this time I'm folding it over here. And if you notice, 2 spaces, 2 spaces, these are all 2 spaces away, and so is this. So I reflected it over that axis. So those are reflections. And then we have a rotation right here in purple. So if we took it and rotated it like so, that's a rotation. So we can rotate around a point. And we'll learn how to do that. But if we rotated it around different quadrants, okay, now I can't do it here exactly, you have to work with me here, but if I rotated it over into this quadrant over here, it would end up looking something like that. Like, see what happens? I did in 2 moves here because that's all the board would allow me. But that's what it looks like if it rotates in. And you can rotate it more than one section, and we'll talk about that. And last but not least, the one we kind of alluded to earlier, the blue one, the light blue, is called a dilation. Notice it got bigger. You can make things bigger or smaller by a factor. Have you ever done any models or heard them talk in movies about a scale figure? It gets bigger or smaller. That's what they're talking about, dilating. Also, if you think about your pupils dilate, they get bigger and smaller with light and darkness. But we'll get to that later. So translation. We're going to be able to draw a translation on a coordinate plane. So, a translation or a slide is a transformation that moves all the points of the original figure the same distance, the same direction. So here we have a triangle JKL is going to move to where MPQ is. So, a vector. We use an ordered pair, AB. To translate a point along a vector, AB, we add A to the x-coordinate and add B to the y-coordinate. So, this is a positive move, and we can use positive or negative numbers. So let's say our point here is at negative 2, 3. Okay? And we want to move it up and to the right. And you've done this before when you did slope in algebra. When you had a point and you moved up and right. Similar idea, except we're not doing it as a fraction here. We're just going to add to the x and add to the y. So if you notice, we have negative 2, 3. So when we add 7 to the negative 2, the x, we're moving to the right 7 spaces. And when we add 4 to the y, we're moving 4 spaces to the upward area. So we're literally going 1, 2, 3, 4, 5, 6, 7. And then we're going 1, 2, 3, 4. And it ends up moving over there. So I've just moved that point right 7 spaces and up 4. Right 7, up 4. And its new point is at 5, 7. Now the only difference between slope and this is now we're going with our x first and our y in alphabetical order. Vectors. Describe in words translation represented by each vector. So, note that these are both positive. And if you think about the coordinate grid, going up is positive and going right is positive. And going down is negative and going left is negative. So think about that. So if I see 2, 5, okay, remember, x is our left and right, and y is our up and down. So this is going to be 2 to the right, because it's positive, and 5 up. Remember, x, y, left, right, up, down. You need those arrows to help you. Go ahead. And negative means left. So left, 3, up, 8. Describe each translation using an ordered pair. So 2 to the left. So that's negative 2. And 1 unit down, that's negative 1. 8 units right, positive 8. 10 units up, positive 10. So, more with vectors. Find the translation vector that slides the blue preimage to the green one. So all you do is say, pick a letter. It doesn't matter which letter you use. I'm going to go with E. And here is my new E with that funky little E prime. Okay? And since I always go X first, I'm going to count over 1, 2. Notice it lines me up perfectly. So I moved right 2, and then how many did I go up? I went up 1, 2, 3, 4, 5. And you can check it. How about G? 1, 2, 1, 2, 3, 4, 5. F, 1, 2, 1, 2, 3, 4, 5. Each time. Okay, moving from blue to green. X, so from M, going to M prime, I have to go 1, 2, 3 to the left. And then I'm going to go 1, 2, 3, 4 down. So that vector is -3, -4. And again, I can do it with any of the other ones. 1, 2, 3 left, 1, 2, 3, 4 down. And I end up at L prime. Okay, translations on the coordinate plane. So first off, we're going to identify the preimage. So where is I? 1, 2, 3, 4, 5. -5. 1, 2, 3, 4. -4. And Y is at -2, 0. W is at 1, 1. And P is at -1, -2. 1, 2, 3, 4. -4. Okay? Now, where's the new image? Well, we're going to translate it 0, 2. So 0 on the X means it's not moving left or right at all. And the 2 on the Y means we're just moving everything up 2. So up 2, up 2. There's Y prime and W prime. Up 2, there's P prime. Up 2, there's I prime. Now, what are my new locations? Well, I prime is still out at -5 because we didn't move left or right at all, but now it's only down 2 spaces. And Y is still out 2 spaces to the left, but now it's up 2 higher. W prime is, again, 1, but now it's up at 3. And P prime is still left 2, and only down -2. Okay, again, let's identify our points. C, 1, 2, 3, 4, -4, and 1, 2, 3, 4, up. I, -1, +1. S, 1, 2, 3, 4, -4, 0 for Y. Now, we're going to move 3 to the right, X, 1, 2, 3. Oops, sorry. And up 1. So 1, 2, 3, up 1. That's C prime. 1, 2, 3, up 1. That's I prime. 1, 2, 3, up 1. That's S prime. So actually, one of our dots, one of our corners, vertices, is on the vertex of the former shape. So where's C prime? Well, now it's 3 over to the right, so it's only at -1, and it's moved up 1 from 4 to 5. -1, it was where I was. Now it's all the way over at 1, 2, 1, 2, and up 2. And then -4 was where S was. Now it's at -1 and up 1. And if you just look at the math, -4 plus 3 is -1. -1 plus 3 is 2. -4 plus 3 is -1. 4 plus 1 is 5. 1 plus 1 is 2. And 0 plus 1 is 1. And we'll do the next assignment in class.